Hello everyone, I am Dr. Aksa Habib. I welcome all of you to my YouTube channel MS Chem Insights. Today I am going to discuss about homogeneous and heterogeneous catalysis. So first of all, I will discuss about catalyst. A catalyst is actually a substance that alters or speeds up a chemical reaction without being consumed or permanently altered during the course of process. And catalyst decreases the activation energy for a reaction, which is the minimum amount of energy required to start a chemical reaction, and thus helps the reaction to proceed quickly and more efficiently in the presence of catalyst. Here you can see these are the reactants and they are being converted into products, but for this conversion these reactants have to cross this much barrier of energy, which is called activation energy, and you can see that this activation energy is much greater in the absence of a catalyst, and this is decreased in the presence of a catalyst. And thus catalyst decreases the activation energy, as well as it also provides an alternative pathway for the reaction, because you can see that in the absence of catalyst these reactants have to go through this pathway, and in the presence of catalyst these reactants have to go through this pathway. Thus catalyst plays two roles simultaneously, that is it reduces the activation energy and it also provides an alternative pathway which is easier as compared to that in the absence of catalyst. In the biological system, the catalysts which are used to carry out biochemical reactions are called enzymes, which are usually proteins. And these proteins contain some specific sites called active sites, which help to bind the reactants, which are called substrate. And when these substrates are bound with the active sites of enzyme, the enzyme substrate complex is formed. After the formation of complex, the reactants are converted into products, and in the final step these products get separated from the enzyme, and you can see this enzyme or catalyst is regenerated without any permanent change. Thus catalyst is released and regenerated in its original form. Before going into the details of homogeneous and heterogeneous catalysis, we must know the difference between state and phase of a matter. State is actually the natural form of matter in which it usually exists. For example, sodium chloride naturally exists in solid form at room temperature, so its state is solid, and water exists in liquid form, and carbon dioxide exists in gas form at room temperature. So these are their natural states. On the other hand, phase is a temporary state of matter which is physically distinctive, and uh, is a region of space where all the physical and chemical parameters of the matter are uniform. For example, density, chemical composition, and temperature. For example, in the case of true solution, here you can see a beaker full of water. When we dissolve copper sulfate crystals in this water, the solution of copper sulfate turns blue, which is uniform, and you can see that the whole matter is now in liquid form, although copper sulfate before dissolution was in solid state, but now its state has been converted into a phase, that is liquid phase. So whole mixture behaves like liquid. Thus, this temporary state of matter, especially in context of copper sulfate, is called its phase. Homogeneous catalysis. In homogeneous catalysis, catalysts and reactants exist in same physical phase. For example, here is the reaction of sucrose and water, which is called hydrolysis of sucrose, which is obtained from sugarcane in the liquid form, and water naturally exists in liquid form, and sulfuric acid, which acts as a catalyst, is also in liquid form. So the reactants and catalysts, they all exist in same physical form, that is state. So this catalysis results in the formation of glucose and fructose, and this is called homogeneous catalysis. These reactions are usually faster than heterogeneous catalysis, but there is a challenge that the recovery of product and catalyst is usually difficult because of the same phase of reactants and catalyst. Heterogeneous catalysis. In heterogeneous catalysis, the catalyst and reactants are in different physical forms. Usually catalyst is in solid form, and reactants may be in liquid, gas or solid form. And these types of processes usually occur in different steps, although they are continuous, but for the sake of convenience and simplicity, they can be divided into four different steps. For example, here is a solid surface of nickel catalyst, which provides active sites for these reactants, which is actually hydrogen gas, and this gas is being adsorbed on the surface of nickel, and during the adsorption process its bond is broken and new bond between hydrogen and nickel is formed. Actually this is a weak physical force, but this force is much powerful that it breaks the mutual bond of hydrogen atom. In the second step, another reactant, that is unsaturated hydrocarbon or ethene, is being adsorbed on the surface of nickel catalyst, and during this adsorption process the bond between carbon and nickel is being formed, and the pi bond between carbon and carbon is being broken down, and as a result both the reactants, that is hydrogen and ethene, are now activated for the reaction which occurs in the third step. The hydrogen is added in this unsaturated hydrocarbon, and in the last step the final product, that is now saturated hydrocarbon or ethane, is getting dissolved from the surface of nickel catalyst, and you can see the catalyst is now regenerated without any permanent change. As we have divided this whole process into different steps, any of these steps may be slow step which determines its rate, and thus it may be called as rate determining step, which is slower step which helps to determine the rate of reaction. But overall a rate of reaction can be faster because of the presence of catalyst, but this is not as much faster as that of homogeneous catalysis because of different phases of reactants and catalyst. So this was about the basic introduction of homogeneous and heterogeneous catalysis. If you have any question, you may ask in the comment box. And for the details of mechanism of homogeneous and heterogeneous catalysis, the next lecture is being released very soon. Thank you very much for your attention.